Hello everybody, I'm Babak Saremi, market researcher and data analyst. Today I'm going to finish the discussion on cleaning and preparing data in SPSS, and I'm going to talk about outliers and missing data and how to deal with them and what are the remedies for them. Just note that the level of the contents are intermediate. So if you are not familiar with the basic terms of statistics like histogram, p-value, or normal distribution, I suggest you to start with basic trainings first. So you can find very good sources on YouTube for that, or you can use the lynda.com website. Here is an overview of the contents of the last video and this video. So if you remember in the last video, I talked about univariate, bivariate, and multivariate data analysis challenges that we may face, including normality, linearity, and homoscedasticity. And also I talked about the tests by which we can test the challenges in data analysis techniques, and also I covered the remedies that we can use to deal with those challenges. And today I'm going to talk about missing data and outliers and the tests that we can use to recognize outliers and missing data and to analyze them. And also, I'm going to talk about the remedies of each issue that we may face. Also, I remind you of the factor analysis that I'm going to talk about in the videos of multivariate data analysis. So let's talk about missing data first. There are four important questions in dealing with missing data. First, are they ignorable or not? Second, how much missing data are there? Do you have too many missing data or just a few? How random are they? Are they really random, or they're non-random or systematic? And what method is best to handle missing data? Answering to these questions is very important because they will help you to deal with the missing data in the best way. So to test the randomness of missing data, you can easily use t-test to check the relationship between y's and x's, and I will talk about it later. And if missing data are not random and are from independent variables, you can use them in the calculations, or just run EM method or expectation maximization method to guess the missing data. And I will talk about it later too. And missing data in dependent variables are to be removed. And if the missing data are random, you can use one of the techniques from the next slide. And a very important point is that missing data like linearity, normality, and homoscedasticity is not essentially bad. And you actually have to find the reason behind the missing data. And for example, find out why some respondents didn't respond some questions, and if the missing data are the result of the bad data entry. There are basically two methods in dealing with missing data. The first one is complete case approach or listwise, and it is used when your sample size is large and the relationships between and among the variables are very strong, and it only enters the complete cases. And the second method is all available data, or pairwise, in which all data are entered and missing data are filled in with correlation, mean, or standard deviation. And it's good when the relationships are not that strong and the number of missing data is low. So for the imputation, we can use hot deck method, which is getting data from another sampling population. Cold deck method from outside of the population, like the past surveys, alternating one case with another similar case, uh, and imputation by using mean when the relationship is strong, and regression when the missing data are too many and relationships don't affect generalization. And these are some important rules of thumb. If missing data are less than 10%, you can use any method except for pairwise method. If they are between 10% and 20% for non-random missing data, you can use EM method. And for random missing data, you can use any of listwise, case, or min imputation, hot or cold DEX, or regression method. And if missing data are more than 20%, you can use EM for non-random and regression for random. Okay, to deal with the missing data in SPSS, we have two choices. We can analyze the missing data and impute the values manually, or remove or keep the variables or cases. Or we can let the SPSS do it automatically. So here we have a data set, and it has 70 cases and 14 variables, from which 5 variables are categorical and 9 variables are numerical. And you can see some missing data here. So we are going to analyze and impute data. Easily go to Analyze, Missing Value Analysis. Now I select V1 to V9 as quantitative variables and V10 to V14 as categorical variables. And I also call ID to case labels. And this is the maximum of categories, and you can change it. Now I go to Patterns, check tabulated cases grouped by missing value patterns, and cases with missing values sorted by missing value patterns. And sort variables by missing value patterns is checked automatically here, and you can uncheck it, but let me leave it for now. And this one is optional, so I'm not gonna do that. So just okay, okay, and this is the result. We have a univariate statistics. For example, for V1, we have 49 cases, and this is the mean standard deviation. And for other variables, we also have those information. Here, we don't have data for mean and standard deviation because V10 through V14 were categorical. And we also have the number of missing data for each variable and number of extreme values. And you can see from here that V1 has the most number of missing data, and it's about 30%. So it is a candidate for being removed. And we also have another table which is important. It's missing patterns table. On the left hand you can see the cases, and on the top you can see the variables. So you can check which variable or which case has the most number of missing data. And these S's shows the missing data. So each S shows one missing data, and it is in order from least to the most number of missing data. So as you can see, V1 and V3 has the most number of missing variables. And this one tabulated Pattern is also another great help for you to choose which case or which variable um, are candidates for being removed. But removing a variable, removing a case may not be that important because if you have, enough uh, and a good sample size. But for deleting or removing variables, you have to have, theoretical evidence and theoretical reason. So don't uh, delete or remove the value without any, reason and without theoretical background. So let me go back to the missing value analysis. Now I remove V1 because it had the most number of uh, missing data. And now I go to descriptives and check t-test with groups formed by indicator variables and include probabilities in table. This test is to check the relationship between variables or among variables in terms of the variance. So if the p-value is lower than 0.05, it would be significant and shows that there is a significant relationship between two variables. So the variables could be, candidates for being removed. So let me continue and then, okay. Yeah, this is the univariate statistics table again. And this table is a new one. On the left hand, you can see the variables, and on the top, you see the variables again. So it shows the relationship between variables. So for example, for V2, and in this row, we can see that we have some p-values which are lower than 0.05, like this one, this one, this one. So now V2 has three uh, significant p-values with V4, V5, and V6. And so it could be a candidate to be removed, V2. And V3, for example, if you look at the p-values, you can see that it doesn't have, any significant relationship with other variables. So it's a good variable to be kept. So if you check all of the variables, you can see that V2 has the most significant p-values. So it is a very good candidate for being removed. And these are the tables that we had in the last result. So let me go to the missing value analysis again. Now you can check which estimation you want to do. Just note that this is not an imputation. It will just give you, some information on mean, standard deviation, correlations, and other factors from which you can choose which method you will, uh, opt to impute data manually. So here I check pairwise, EM, and regression. Here we don't change anything. This is the EM method, and it shows the iteration numbers, which is 25. You can change it, but I'll leave it for now. And regression, yeah, you can see that it's residuals, and then it's normally uh, selected, and we don't change anything else, just okay. And now you can see that, for example, for pairwise statistics here, we have pairwise frequencies, pairwise means. These are the means. Uh, and it's very important. Mean of quantitative variable when other variable is present. So, for example, for V2, when V3 is present, the mean differs when only V4 is present. And pairwise standard deviations, pairwise covariance, and pairwise correlations. And this is the EM method. And you can see the significance level. And these are EM covariances, EM correlations. And this one is for regression. Regression covariances, regression correlations. So these tables will help you to check which imputation method would give you the best results. However, based on the rules of thumb that I mentioned before in one of the slides, it's better you check those rules of thumbs first and do the imputation manually. But most of the statisticians, they use, the automatic way of dealing with missing data in SPSS. So let me talk about that. Yeah, okay. I just go to Analyze, then multiple imputation, and first I can analyze pattern before imputing missing data. So let me do that first. Analyze patterns, and I choose V1 through V14 to analyze across variables. We also can have an analysis weight, but I don't use it now. And summary of missing values, patterns of missing values, variables with the highest frequency of missing values are checked automatically. And this is the number of variables displayed. And this one is the minimum percentage missing variables to be displayed. I want every variable to be showed here with the missing data. So I choose a very small number. So just okay. Okay, now you can see three pie charts. First one is for variables, which shows that 100% of variables they have incomplete data or missing data. And from the cases, about 63% of the cases have missing data. And for the values, only about 11% of values are missing. And this one is the variable summary ordered by the most number of cases with missing data. So V1 has the most number of cases with 30% or 21 cases. And then it is V3 with 24%. And we have also valid number, mean, and standard deviation. And here, again, V14 and V through and V12, V11, V10, and V13, they are categorical. So this is why they don't have mean and standard deviation. And this one, it is, a kind of diagram which shows the missing data in form of red partitions. So the reddest part of the shape is like here. So it shows that V1 to V3 has the most number of missing cases. This one is the number of missing cases. So V1 and V3 are the good candidates for being removed. And this one shows the missing value pattern in terms of percent sum, number of the percentage of cases. And let me do the imputation. Just go to Analyze and missing multiple imputation, impute missing data values. And now I choose V1 through V14 as variables in model. We also can have the weight. And this is the number of iterations. It's set on 5 automatically, but I can change it to 1, 2, 3, 4, or anything that I want. Let's leave it unchanged for now. And then I have to set a new name for a data set that now, based on the iterations, it will give me. So I will name it missing 2. And then I'll choose the method. You can choose the automatic, which I think is better, or you can choose the custom and do the Monte Carlo or monotone test here, but I prefer to choose the automatic. And constraints, if you click on scan data, you can see that for every variable, it gives you the percentage of missing data and the minimum, the maximum, and for the iterations, you can set some constraints. For example, you want V1 to be from a minimum number to a maximum number, or you want a round number, or you can impute and use as a predictor, or just impute only, and other things. I'm not going to change these things now. And for the output, I select imputation model and descriptive statistics for variables with imputed values. And OK. Yes, you can see the multiple imputation, the methods that are used. Yeah, and for example, here, logistic regression or linear regression are used for the imputation method. And here you can see the descriptive statistics for every variable in a separate table. So this one is for V1, and it includes mean, standard deviation, and etc. It's imputed values and complete data after imputation. So you can see that the number of number of the cases in original database here for V1 was 21, but here we have 70 completed cases. So it's changed now for V2, V3, and etc. But now we can go to the newly created file and data set, which is titled missing 2. And here from the upper right hand, you can see that this one is the original data that we have with the missing data. And now I can, for example, choose the first iteration, and you can see that the data are imputed. SPSS automatically chooses those rules of thumb that I mentioned before on one of my slides. And you also can check those imputation rules of thumbs uh, to see if uh, the imputed values are those ones that you want or not, based on the analysis part. So this one is the second iteration, and this one is the third, and this one is the last iteration. So you can see that data are imputed completely. So based on the iterations that you have, you can check the differences between original data among original data and the other iterations. So for example, you can go to Analyze, Compare Means, Independent Sample T-Test, and here, yeah, I chose test variables, all of the uh, numerical variables here, and V10, for example, as a grouping variable. So yeah, I choose 0 for group 1 and 1 for group 2, and then okay. And now you can see the group statistics for original data and iteration number 1 here, iteration number 2, and etc. Which has n, mean, standard deviation, standard error mean, and also for the pooled part, we have the other columns: fraction, missing information, relative increase, variance, and relative uh, efficiency. And here in the independent samples test, this is for original data, and we have also the table for iteration number 1, number 2, number 3, number 4, number 5, and also we have for the pooled part. And you can see that we have F-test, significance, T-test, degree of freedom, significance for two-tailed, mean differences, standard error differences, and 95% confidence interval, level of difference, lower and upper. And for the pooled part, we have fraction, missing information, relative increase, variance, and relative efficiency. But from the significance test, you can check the differences between groups uh, in terms of the iterations. Let's go for the outliers. Okay, the last challenge to be faced in cleaning and preparing data is outliers. And outliers, as you may know, are the extreme values far greater or less than the standard levels of the values. So for univariate data analysis techniques, we use standardization, which means the average of 0 and the standard deviation of 1. For bivariate data analysis techniques, we use box plots for uh, one numerical variable and one categorical variable, and scatter plot for two numerical variables. Here is box plot, and we also had some box plot in the last video, and you can see the outlier over here. And for multivariate data analysis techniques, we always use Mahalanobis D-squared test. Again, for univariate data analysis techniques, for the sample sizes smaller than 80, cases with standardized score of 2.5 and greater, and for larger sample sizes, cases with standardized score of greater than 4 are outliers. In the bivariate data analysis, we compare independent variables and dependent variables in box plots or scatter plots. It's based on the nature of the variable, if they're categorical or numerical. And for the multivariate data analysis, we can test the variating regressional factor analysis. The amount of d squared divided by degree of freedom greater than 2.5 for small sample sizes, and mm, the amount greater than 3 or 4 for large sample sizes are considered as outliers. And the very important point again is that outliers are not essentially bad, and you have to find the reason behind them. If, for example, they have happened because of the uh, some errors in the data entry, or sometimes they have happened because of the technical issues. For example, in the online surveys that you have, you can set some uh, restrictions, for example, for just getting valid values, but you forgot to do that. Or some other, reasons may happen. So it's very important to focus on the reason of the outliers, to check if you have to delete the outliers or ignore them, or let them be there. Okay, to test the outliers in SPSS, I have divided the discussion in three parts. Uh, First, I will go to check the univariate outliers. You can easily go to Analyze, Descriptive Statistics, and then Descriptive. And for example, I will choose X19 to check the outliers, and just don't forget to check this one, save standardized values as variables. So when you click on OK, go back to the dataset, and you can see that one new column is added with an MZ score of X19. And you can see some negative and positive numbers, and just you have to check which number is greater than the absolute amount of 2.5. And that one could be a kind of, good candidate for being considered as an outlier. So I think we don't have any here. We have this one, case number 22. Uh, it could be seen as an outlier or not, because um, it's based on the case which is uh, you know very sensitive or not. If you're very sensitive about the case, you can see it as the outlier. If not, you can ignore it. And what about the others? No, we don't have any outliers here. But again, if the value is greater than the absolute amount of 2.5, it can be seen as an outlier. For the bivariate data analysis, you can go to legacy dialogues, and if one of your variables is categorical and the other is numerical, you have to use box plots. So I just choose box plot, for example, a simple box plot. Or if you have, more than one variable to test, you can use cluster. There is no problem. So let me check just one variable. So I have to check the variable based on a category basis. So for example, let me check the satisfaction. And for the categorical variable, I can choose the customer type. Don't change anything else and just OK. Yeah, you can see three box plots here based on the categories of the customers: less than 1 year, 1 to 5 years, and over 5 years. And you can see that for the customers with less than 1 year, uh, we have two outliers here, case number 96 and case number 13. And this one is uh, really easy to do. If you have, two numerical variables, just go to graphs, legacy dialogues, and scatter plots. And again, you can, for example, choose the simple scatter plot or matrix scatter plot if you have more than, one variable to test. So let me check the simple scatter plot, and I have to choose two numerical variables. So let me check the product quality as a y-axis and, for example, satisfaction. Finding the outliers in this way is not that easy, but the important point is that you will consider this one based on the 95% of the confidence level. So when you get the result, you can see that we have the diamond shape or oval shape, scattered the dots or circles. And if you draw a circle or an oval here like this, then the dots or circles outside the oval or diamond could be seen as an outlier. And as I mentioned before, it's not that easy. So you can just focus on the number of the circles outside the oval or diamond. And then for multivariate data analysis, we have to test the Mahalanobis test. So let me close this one, and you can just go to Analyze, to regression. Let me find it. Regression, and then linear. And you have one dependent variable. Let me choose x19, and some independent variables. Let me choose these four variables: product quality, e-commerce, technical support, and complaint resolution. So just the important point is that you have to go to save option and just check the Mahalanobis test. Now, after running the test, you get some, results, coefficients, and residual statistics. I will talk about them in the multiple regression. But here, now you have a new column named Mahalanobis 1, MAH1, which is Mahalanobis D square. And you can see that some numbers are very high and some are not that high. So still we cannot say which one is an outlier. So we have to check the function of d squared divided by a degree of freedom. So I will go to transform compute variable. Let me name it d2 by df, d2 by df, and uh, just select the last column which is added recently, this one, and divided by degree of freedom. Because we had five variables, one dependent variable and four independent variables, so the degree of freedom is 5 minus 1, which is 4. And that's okay. Now you have a new column, and because the sample size is not very big, it's just 100 cases. So let me sort the data here. Yeah, we can sort it ascending or descending. And you can see here that we have 5 cases which are greater than 2.5. And these 5 cases could be seen as outliers. So we don't delete them. We have to find the reason behind it, why they are, far from the central point, and why they are seen as outliers. And then we decide for that to keep them or to delete them. It was my pleasure to be with you, friends, today. In the next videos, I will start topics on parametric and non-parametric hypothesis testing using SPSS and or Microsoft Excel. Have a clean data.